In this video, we're going to talk about multiplication. So just like with addition, let's define what multiplication looks like. So for this, for any whole number, R and S, the product, that's the word we use for multiplication, of R and S is the sum with S, the sum with S occurring R times. Or in other words, R times S means that we add S. Oops, supposed to be an S. We add S R number of times. So there's R S's here, or R times. Okay. So however much R is worth, we're adding S that many times. Okay. Quick note in particular for the future. We call R and S factors. So that word factors is something I want us to kind of remember for the future. So when we say the word factor, we want to think of them as like a multiplication. Okay. So most of us are familiar with the idea that multiplication is just repeated addition, because that's basically what this is. Let's look at some visualizations of multiplication. So we're going to kind of view this two different ways. One way is kind of simplistic when we're talking about small numbers of or small numbers for this. So the visualizations we're going to focus in on is rectangular arrays first. So like, for example, let's do 5 times 3. Okay. There is two ways to kind of think about this. All right. One way is to think about it as a repeated addition. So I'm taking 3 and I'm adding it to itself 5 times. I'm kind of using the idea of the definition up here, right? Like I kind of went in the same order. So 3 is where the S is up here. So I repeated the 3 5 times. Okay. You could have wrote the 5 3 times and that would have qualified. Okay. So if I'm thinking of this repeated addition, then what I'm doing is I'm taking the number 3 and I'm adding it 3 times. I'm sorry, 5 times. One more. All right, so I have a total of 15. If I count up all the little squares, right? But there's like a nice way of thinking about this, and that's using the multiplication approach. Multiplication, wow, that's not how you spell that. Multiplication approach, which builds on the idea of a rectangle. So thinking of a 3 by 5 rectangle. So 3 on this side, 5 on this side. Here, I gotta erase a row because in order to make it look perfect. Well, it doesn't look perfect, but you know what I mean. There you go. So 3 on one side, 5 on the other. And then if I counted up the squares, it's 15 total again. I mean, both methods work. One is, and you can even kind of see that if we push those together, it's kind of looking like this rectangle down here. But yeah, both methods work. One's just kind of building on the idea of addition, which is something we just talked about, and then the other is just kind of looking at it in terms of an area, which is this idea of multiplication of 3 by 5, and kind of looking at it that way. The other major visualization that gets used is tree diagrams. Now, I have to openly admit, I'm very bad at these. So I tried to come up with an example that I hope won't be terrible, but I might have to erase. Okay, so let's just say there's a breakfast special at a Waffle House. Okay, and you get however many waffles, and it comes with 2 eggs and breakfast meat. Okay, now for simplicity, I'm going to go ahead and say that the eggs or the 2 eggs could be prepared 3 different ways. Okay, let's say scrambled, over easy, which is when you see the yolk, and then fried. Or some people have a different word for that, but yeah, fully cooked. Okay, so scrambled, over easy, fried. Okay, and then let's say for the breakfast meat, we just have 2. Let's just say it's bacon or sausage. Again, I'm just trying to simplify it because I'm really crappy at these pictures. Okay, so here's how we'd form the tree diagram for this. So the idea is we start with our first choice. So that we make with this particular breakfast meal, right? You get your waffles, but then you have to choose how you want your eggs and then what breakfast meal you want. Okay. So the idea is I'm going to take the fact that I have 3 ways to make the eggs, and I'm going to separate that into 3 different areas. Maybe went a little bit too long on that one. Okay, so each one of these is representing the different types of eggs. So this would be scrambled. This one's over easy. And then fried. Okay. Then from here, I'll just kind of put little dots at the end for endpoints. We then have a choice between bacon or sausage. But every one of these has that option. Oops. So here we could have bacon or sausage. Bacon or sausage. And what this does is it shows us all the possible breakfasts we can have from here. Okay. Here, I'll again try to do little endpoints just to give me a nice point to work at. So the first option means that I would take scrambled eggs with bacon. Okay. So scrambled, oops, with bacon. This next option is scrambled with sausage. And so forth. So over easy. It's a sad looking E and A, sorry. Over easy, bacon, over easy, sausage, fried, bacon, and then fried sausage. Okay, so there we go. So we have a total of 1, 2, 3, 4, 5, 6 options from this special. 6 options to choose from. All right. And we could have seen that if we had simply taken the fact that there were 3 options for eggs and then 2 options for the breakfast meat and got 6 options from there. Okay, so it's a multiplication. Isn't it exciting? But tree diagrams, you kind of draw it out the options like that. It's a really good visual, but like I said, I mean, look at how sloppy mine is. I do my best. I'm not very good at it. There are much prettier ones to find, especially in the book. But yeah, there you go. That's how you do a tree diagram of the multiplication. Okay, but I also want to model how we're working through multiplication, in particular when we start working with much larger numbers. Okay, so we don't really want to do tree diagrams with a lot larger numbers. I kept it really simple. And even you know, it starts getting a little bit cumbersome too with the rectangles. There are ways of doing it. In fact, let's look at it. Okay, so let me write this down. We're going to look at models for algorithms. So we're still kind of doing visualization, but we're going to kind of break it up into two kind of ideas. So the first model for algorithm that we're going to kind of look at is the algorithm of repeated addition. When we think of a multiplication as a repeated addition. Okay. For instance, let's say we want to multiply 145 times 3. Okay, so I'm going to display 145, and I'm going to use the techniques we did in you know, the previous sections. So 145 would be a 10 by 10 square. And I'm going to, just for the sake of time, I'm going to just draw a big square, but this represents a 10 by 10 square. Okay. And then, so that's 100. And then 40 would be represented with 4 tens columns, right? Each of these are supposed to represent 10 squares. Okay. And then 5 ones. So those would be single boxes of 5. Okay, there we go. So that's 145. And I would need to do this 3 times. Okay, so now that you kind of get how I'm going to do this, I'm going to do it a little bit quicker, which means I'll be a tiny bit sloppier, but that's okay. One more. Okay. Now with this method, we would have to use the idea of regrouping. Okay. We'd be keeping track of how many hundreds blocks we have, but we would also be taking the tens blocks, or the 10, like the little skinny tens ones, and we'd be grouping them together to create hundreds as necessary. So right now at the moment, I have 1, 2, 300. Okay. But I know that 10 of these little rectangles here, right? 10 of these add up to 100. So how many rectangles do I have? Well, here, let's go ahead and I'll highlight them that add up to 100. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10. Those are going to be reformed into a rectangle. I'm sorry, a square, a 100 square. Okay. So that's now my 4th square. So I have 400s. Okay, same thing can be done for the singles. Those could be joined together to give me, sorry, I'm gonna switch colors. Those could be joined together to give me a 10. So I'll need 10 of them to do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those will be all accounted for now as a single column. I'll use the pink highlighter to indicate that those are those pink ones I just shaded up there. All right. So how many tens do I have? Well, let's see. I have this one here. Let me not draw it inside. Let's draw it outside here. So 1, 2, 3 tens. And then how many hundreds do I have left? I'm sorry, how many ones do I have left? It looks like I just have 5 ones. So I'll add the 5 ones. So there we go, 435. When we kind of do this regrouping game, okay? Now, you can visually regroup. In other words, you could be like, okay, so each of these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 become a 1, plus I had the the other 3 to start with. And okay, there's my 4 total. And then I'd count off, okay, so now doing the ones, the same thing. I'd be like, okay, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that becomes a brand new little column 1. And then I have 2 already sitting there, leaving me with 5 ones. So, I mean, you could kind of do it over off to the side, regrouping and crossing off what's getting grouped together. I just indicated it with a highlighter. Same idea. Okay, so whether you redraw it or you kind of group it together using color coordinated, that's the idea, is that we are joining them together in order to form the bigger blocks. Okay. The other method, other than repeated addition, is using the idea called partial products. So partial products builds on the thought that sometimes the multiplication is easier if we think of them as smaller multiplications. Let me give an example. Let's say I wanted to multiply 18 times 23. Okay. So to do this, I'm going to build a rectangle out of 18 times 23, but I'm going to be really smart about how I build the rectangle. So when I build a rectangle of 18, okay, that means I have a block of 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's my block of 10. And then in addition to that block of 10, I have some 8 little singles down here. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this represents 10 and 8. So a giant column that's totaling up to 18. Okay. I'm going to use that same logic to do 23. Okay. I'm going to do 10 going this way. Try to make it straight. Come on. There. Okay, 1, 2, 3, 4, 5, 6, 8, 9, 10. And then I'm going to do another 10. 5, 6, 7, 8, 9, 10. So this is 10. This is 10. I think that's kind of the divider between them. Okay. And then another 3 at the end. Here, I'll do that in red. 3 single blocks at the end. Wow, that's just terribly drawn. I'm sorry. Let me fix it. Okay. So there's 23. And then when I start to form my full rectangle, now I'm going to kind of be loosey-goosey about it. My full rectangle, I have basically, I'm kind of already dividing myself here into segments that are easier for us to figure out. So first I highlighted the 2 green ones, which were formed by doing 10 by 10. So these 2 green squares are 100 squares each. So I have 2 100s. Okay. Now down here, I have an 8 by 10 rectangle and another 8 by 10 rectangle, or 80 blocks each. Top over here, I have a 3 by 10 rectangle, which would have 30 blocks. And then down by here, down here I have an 8 by 3 rectangle, or 24. Okay, so this isn't so bad to add now that I've kind of done that. So let's see, that's 200 plus 160 plus 54, 360 plus 54. So let's see, I get 414 when I add that together. And there we go. So you're taking something that's a little bit more complicated and you're breaking it into multiplications. So let me write that down. We are breaking into smaller multiplications. That's the idea. with partial products. Okay, now, just like with addition, we do have some number properties that we're going to go through. And then I'll go ahead and discuss those quickly. So we have already seen these when we went through addition, but now we're going to do it for subtraction. Okay. The first is the closure property. Now we talked about that when we talked about the idea that if you added two things together that were similar and you got the same type of a thing, that's closure. For multiplication, what we would be doing is for any whole numbers, A and B, their product is a whole number. In other words, if I take any whole numbers and multiply them together, I'm going to get a whole number when I do that. I'm not going to all of a sudden spontaneously get a decimal. Okay. Plus, whole numbers are positives. So when I'm multiplying positives, I'm always going to keep getting positives. Okay. So that's useful. Yeah. So it's closed. We can multiply two whole numbers together and it's going to stay a whole number. All right. Then we have the identity property for multiplication. We had an identity property for addition. That was when we added with 0. And when you add with 0, it doesn't do anything. So with multiplication, the magic number is 1. 1 is the identity for multiplication. And how it works is for any whole number B, 1 times B is always going to equal B. We also have the commutative property for multiplication, just like we did for addition. Commutative property says that we are allowed to switch the order that we multiply things. Oops. Sorry, my computer lagged a second. Wow, that's a terrible why. Let me fix it. Commutative property. So if you have A times B, that's the same as B times A. And then we have an associative property also that works for multiplication. Associative property is when you prioritize what you do first. So if we have a multiplication between 3 terms and we have parentheses around 2 of those terms, but they're all being multiplied, we don't have to multiply those 2 terms first. We can go ahead and change the order. I can group together instead the B and the C if that happens to be easier. That's the associative property. And then we have the distributive property. And this is the first one that's kind of new to this section. So all the others we kind of talked about previously, but new to this section is the distributive property. And the distributive property combines multiplying and addition. So if you have A times B plus C in parentheses, you can multiply B and C by A and then add those together. So basically you're taking A and you're timesing them by both things inside the parentheses. You kind of might remember that little way of remembering it. Okay. So there's the properties. And I'll just show an example maybe of the distributive property, just because that one's the new one, and hopefully we feel comfortable with the other ones. So let's see. One of the ones they like to do is one we're going to use later when we do the mental calculations. Okay. But it's something like this. It's like, let's say we have 35 and we're going to times it by 12. It's easier, or it's the same thing to think of this as 35 times 10 plus 2. And now using the distributive property, I can multiply 35 times 10 plus 35 times 2. 35 times 10, that's an easy one to figure out. That's 350. 35 times 2 is not too bad. That's 70 when you add those together. And that adds up to 420. So it can make some math easier when we're doing some mental math, but I will save that for a different video.